Do it without doing. Okay, at least that's what my teacher said. It essentially means that uh, they want us to evaluate this determinant without expanding, right? By using some ideas. Let's say you might want to use row operations, or there might also be other ideas most of the time we barely determinant using row operations, and they tend to be pretty helpful. But for this problem we will go with a slight different approach, and yeah, and you will also understand this new idea and you can implement it somewhere. So yeah, let us begin. Okay, first of all, let us try to understand what this determinant will give us, right? Okay, so if we try to evaluate this determinant, might notice that it will be something like, so okay, so this multiplied by this minus this, right? So this is second degree expression, and this is 4 degree minus 4 degree. So essentially total 6 degree expression, right? Again, if I go with like x square, um x square, that will also be x square, and we will cancel this out. So 4 4 and then 2 4 6, right? And if you also go in this last one, it will also be 60, degree 6 expression. So basically, like you will have a homogeneous 6 degree equation if you try to balance the determinant, right? You will also have homogeneous because all of them, like over here, all of them will have two degrees, all of them will have 2 degrees. So like there will be no expression with 5 or 4 degrees. You can see that if you try to just evaluate homogeneous 6 degree expression, right? Okay. And next thing is also the expression will be symmetric about x, y, and z. The way you can see that is the way you can see that is just like how there are like two x squares over here, and there's y plus z square. Similarly, there's two y square x plus z square. Similarly, two z square x plus y square. You see that like every variable has equal contribution in this determinant, so the answer will be symmetric, right? Because every variable has its equal contribution, so that would be symmetric, right? So I can also say this as homogeneous 6 degree symmetric expression. That will be our answer. I mean, by symmetric, I mean that the terms involving x, y, z would be same. That means, let's say if I have x square y z in expression, there should also be y square x z. There should also be z square x y. So this is the symmetric expression. Yeah. This is actually like circular. I also need to have x squared zy. Basically, these two are same, but still, I also need to have y squared zx, z squared yx. So yeah, this is basically a symmetric expression. Or yeah, like circle. Like even I could have just written the first three because the second three were just same. Okay, now you get the idea of symmetric expression and also homogeneous 6 degree, right? Now let's try to see how we find that the expression, right? So let's say the final expression we represent by a function of x, y, z, right? Now we have like this function x, y, z as some expression, right? Now I guess you learned it in the factor theorem that if I substitute x equals to a, and this expression becomes zero, right? When this expression becomes zero at x equals to a, then x minus a will be a factor, right? X minus a will be a factor. I guess you know that, right? Of this expression f of a, right? So yeah, we'll try to use this. We'll try to use the fact that when you substitute x equals to a, and if that becomes zero, then x minus a is a factor. And guys, if you know that, now like definitely what we can try over here is, since these x squares are freely like roaming in determinant, of course you might wanna like substitute x as 0 and see if the whole determinant, whole this function becomes 0, right? Because they are free, that can be an obvious choice. So let's see that. Let's do that. So if I substitute x as 0, because, and the reason I'm doing this is, in the reason I'm doing this is, like if you are able to find some factors of this determinant, Then like after we have some factors, like let's say we get, let's say, x as factor, y as factor, z, like this things as factor, and then we'll have some idea of how the expression will look, right? And that can help us like solve it further. So that's the idea. Okay, so if I substitute x at 0, this will just be determinant of y plus z square, 0 0, y square z square, uh, this is again y square z square z square y square. Am I right? Yeah, okay. Now guys, if you try to see this expression, you will notice that since these two like columns are actually identical. I mean, by identical, what I mean is, if I do a, let's say, a row operation, like we can do few row operation indeterminate, right? I can either scale a row, but if I scale a row, then I need to have a constant outside determinant as well. I mean, I cannot really scale a row without changing determinant. But what I can do is, without changing a determinant, I can add a constant multiple of one column to another column, right? So over here also, if I do like, let's say, row 3 is equals to uh, row 3 plus 1 by, sorry, not plus, minus y square by z square row 2, then this third row will just be 0, right? So yeah, that's what I mean by identical. Like they just differ by a constant multiple. So 0 z square, now it's just with 0, and y square minus y square 0, y square minus again y square 0. So you see that the determinant is just 0, right? So since x is equals to 0 makes this function determinant 0, so definitely the one of the factor of the determinant, I mean, if you evaluate determinant, one of the factor will be x minus 0, or just say x. So x is a factor, right? Okay. Similarly, if since like this is symmetric about x y z, if you even try y is equals to 0, z is equals to 0, that will still work. I'll just show you for the sake of completion, but yeah, that will definitely work. Now let's try y is equals to 0. Uh, z square, x square, x square, 0, z plus x square, 0, z square, z square, x square, z square, z square, x square. Now you you can notice that again these two columns are identical because these two just differ by constant multiple, right? If I just make this row operation, that let's say row 3 is row 3 minus uh, uh, x square by z square of row 1. If I do no, not row 1, it's column. Wait, I'm sorry guys, I'm sorry, I'm sorry that I'm writing row over here. It's not row, it's column, I guess. Sorry, this is column 3, column 2. This might have confused you, I'm sorry for that. Okay, so column 3 is equals to column 3 minus x square by z square of column 2, sorry, column 1. So if I do that, it will just be like z square 0 z square, right? X square z plus x square, and then z square. Now x square minus this will just be x square, right? So that's just 0 0 0. So again you see that this is just 0 because like uh, all three elements are 0. So if you try to expand it through this column, you will see that that becomes 0, right? So similarly, you can also check that. So since this is 0, we know that y minus 0 is a factor. That means y is a factor of this expression, right? Of this determinant. Okay. Now similarly, you can just try for z is equals to 0. Again, our determinant will just be 0. So therefore, we will have z minus 0 as factor. So z is a factor. So till now, what we have found out is this determinant is let's say some x, y, z, there are factors and there are some other expressions obviously, because this needs to be a 6-degree homogeneous expression. But yeah, we do know that there are x, y, z in the factor. Now, what something else that you might want to try is, since there are this y plus z, x, z plus x, x plus y, you might consider doing y plus z, these things also 0, but that might not be helpful, right? Because if you just do these zeros, like there like you can definitely now know that y is minus x minus z. But yeah, but I have already checked that, and that's not helpful. But something that can be helpful is, now you might wanna try, if you substitute x plus y plus z as 0, then see if the expression will become 0 or not. Because if that's the case, then again x plus y plus z minus 0 will be a factor, right? Okay, so let's try that. Okay, so if we try x plus y plus z as 0, now you will have y plus z as minus x square, x square, x square, y square, this is y square, y square, this is z square, z square, z square, right? Now guys, again, since these rows are identical, because if you just perform a column operation, let's say, I mean row operation this time, so row 2 is equals to row 2 minus y square by x square of row 1. If you, let's say, do this, the second row will just become 0 and determinant goes to 0, right? Okay, so yeah, since this is 0, now we know that this is also a factor of the determinant I mean, whatever this expression is a factor, right? So till now we know that this is also a factor, x plus y plus z. Now it's already a 4-degree expressions. There is still a 2-degree expression, right? And also, like, there can be some constant, because constant don't really have any degrees, so yeah, they can also be there. Okay, so now let's try to see how, like, now the only thing that remains is a 2-degree expression, right, over here. Now let's try to see, like, how, like, general 2-degree expression looks like. Okay, and also it needs to be homogeneous, since all of these things over are homogeneous. The thing over here should also be homogeneous, and it needs to be 2 degree, and it also needs to be symmetric, right? Okay, if it wasn't symmetric, like, the 2-degree expression would just something like this: ax square plus by square plus cz square plus exy plus fyz plus gxz. So this is the symmetry. This is a homogeneous 2-degree expression. But since they are symmetric, like, for our case, we need not consider this. What we can consider this one: a times x square plus y square plus z square. They will all have same coefficient. Again, b times xy plus yz plus xz. So yeah, our expression over here will be in this form for some numbers a and b, right? So yeah, there can be some numbers a and b. And so yeah, because we have to definitely, like, consider the constant, because these don't have any, like, degrees, but yeah, they can be there. So yeah, now we know that our function is something like this. Our function is, our determinant will be x, y, z, x plus y plus z times a times x square plus y square plus z square plus b times xy plus yz plus xz. So this will be our determinant, and we need to now solve for a and b, right? Okay, so now to solve for a and b, it's not that hard. What you can do is try to, this is also our determinant, this is also our determinant, right? They are same expressions. So what you can try to do is you can try to substitute values for y and z. So let's say if you substitute x as 1, y as 1, z as 1. So over here, from this expression, let's see what we get. So from there we get 1 times 1 times 1 times 3 times 3a plus 3b. So this is 1 times, so 3 times, and this is 3a plus 3b. Now let's see what we get from this other side. From other side, what we just get is determinant of, this is 1 plus 1, 2 square is 4, 1 1 1 4 1 1 1 4, and that evaluates to 4 times 16 minus 1 minus 1 times 4 minus 1 plus 1 times 1 minus 4. Oh wow. So that's 60 minus 3 minus 3. That's 54, right? So we get this equation. 9 times a plus b is equals to 54, which essentially means a plus b needs to be 6, right? Now let's try to get another equation. Let's try to get another equation. Okay, let me zoom in, zoom out, and over here. Now let's start another equation. Let's substitute x as minus 1, y as 1, z as 1. You can do anything. You'll just get to equation and then solve it. So over here, now if we try to substitute these values in this expression over here, this is also determinant, right? If you substitute over there, okay, x is minus 1 and 1 1 minus 1 plus 1 plus 1. So negative 1, positive 1, positive 1. This is also minus 1 plus 1 cancel out. There will be a positive 1. Okay, so till now we just have negative 1 for all of that, right? Now this is 1 plus 1 plus 1, that's 3a. And then this is minus 1 plus 1 minus 1. So just plus 1, 3 plus b, right? So we get this expression. And now let's see what we get for determinant. For determinant, we get y plus z. That's 2 square is 4. Then the x square is just 1 1, and then y square is again 1. Now that's just 0, right? Because x is minus 1, y is 1. That's 1 1 1. Again, that's just 0, right? Okay, so we get negative of 3a plus b as, this determinant will be 4 times 0 minus 1 plus 1 times 0 minus, sorry, this is minus 1 not plus 1, minus 1 times 0 minus 1 plus 1 times 1 minus 0. So that's just 4 plus 1 plus 1, that's 6. So the another equation that we get is this minus of 3a plus b is 6. Is that it? I thought it would be something different, right? Okay, let me check once again. 4 minus 1 minus 1 0 minus 1 plus 1 1 minus 0. Oh yeah, this is negative 4 actually. This is negative 4 plus 1 plus 1. Yeah, okay, now good. Now this is negative 2, right? Yeah, now makes sense. This is negative 2, right? Okay, so 3a plus b will just be 2. Now we know that over here 3a plus b is just 2, right? Now we can easily solve this expression. We can even guess, I guess, without even solving. I think there's still some mistake. Oh yeah, there's mistake, because over here this was negative 1, positive 1, negative 1. So eventually there should be negative 1. There should be negative 1 over here. I'm sorry guys, I'm making a lot of mistakes. Negative, 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 negative. This should be negative, negative. Okay, now it looks good. Now you can just add these two expressions. That will give you, if you just add these two expressions, that will just give you 4a is equals to 8. That gives you a is equals to 2. Now if a is 2, we have a is equals to 6. Okay, wait, now we have b as 6 minus a, right? So we know that b is just 6 minus a. So b is equals to 6 minus 2 is 4. So a is 2, b is 4. Now we finally have our answer. Now the determinant will just be x, y, z, x plus y plus z And now this is 2 times x square plus y square plus z square plus 4 times xy plus yz plus zx, right? Okay, now I can take the 2 common, so this will be 2 times xyz x plus y plus z plus x square plus y square plus z square plus 2xy plus 2yz plus 2xz. Now you guys might not know that this is just the square of x plus y plus z. So this is 2 times xyz x plus y plus z times this is x plus y plus z square. So this is 2xyz x plus y plus z cube. And that's our final answer. And this answer has been verified through Python, right? I evaluated, and then I also checked the answer. This is the answer actually. And to get this answer, really, this method of finding factors helped us a lot, because after we could find it and after we knew that this is homogeneous 6-degree symmetric expression, we could just predict what the remaining expression would be. And from that prediction, now we just need to find the a and b, which we found out by substituting values and then making equations. And that's how we solved the determinant. So this was a completely different way to solve determinant without even expanding. And that's what it's called, do it without do it without doing. Definitely I messed up at some point. Like over here I wrote the row, over here I missed the sign, over here I missed the sign again. I'm sorry for that, but I do hope you enjoyed this like new idea about how you can solve some determinants. So hope it was helpful. Thanks for watching, and I look forward to seeing you in the upcoming videos too.